Alright, a regular octagon is inscribed inside a circle as shown in the figure. The diagonals of the octagon create 8 congruent triangles. The diagonals intersect at the center of the circle. The height of any of the triangles is h, excuse me, while the base is b. The sides of the triangles are located within the circle and are congruent, each with a length of r. What is the area of the octagon in terms of its perimeter, P, and the height of one of the triangles, H, and or the radius of the circle, R? This and or the radius of the circle is kind of leaning me towards that it could or could not be included in the formula. So what's required in this area of an octagon is we now need the value P and H and or the radius of the circle. So when we look at this, we already have H right here in the formula for the area of the octagon. Now again, remember we found out that the perimeter in the last question of the octagon was 8 times b. And I see that in two, they're kind of separated right now. We have 8 and b right there. So if we were to rearrange these, which we can do, we could rearrange it to where this would be 8 times 1/2 times the height times the base, and we can also rearrange it to where it would be 8 times the base times 1/2 times h. Because of the commutative property of multiplication, you can rearrange these letters and multiply it in any order. And now if you notice, 8 times b is more typically just written as 8b. Which we have right there. So now we can just substitute P in right there. So this is the perimeter times 1/2 times H over 2. H times 2. And when you multiply fractions, I was just scanning and I noticed we had this weird fraction right here. It looks different. How did they get H divided by 2 when we have 1/2 times H? Well, they multiplied 1/2 to h, and when you multiply fractions, you multiply numerator to numerator and denominator to denominator. The denominator for h is 1. You can write any number or any letter as a fraction over 1. So 1 times h is h, and 2 times 1 is 1. So that's how they ended up with h halves. So they just multiplied that out and said, okay, well then I have h halves right there. And so our area would be equal to the perimeter times h over 2. And that's how I would go through and answer this question.